Alright, this video is going to focus again on our states of matter, which is what Chapter 2 is all about. However, we're going to look at liquids and gases here. Liquid is a state of matter that does not have a definite shape, but it does have a definite volume. You can see this very easily by when you just pour water or another liquid into different shaped containers. Your liquid will take the shape of that container. So it doesn't have a definite shape. That varies depending on the container and where you put it. However, the volume is always going to be the same. Liquids do this because their particles just have a little more motion to them. They have more thermal energy. The more thermal energy you have, the more movement these particles have. So unlike a solid, these particles are moving fast enough in order to break free from their individual spots. So they can kind of slosh around on top of each other. They don't have enough energy to escape this liquid, but they do have enough to move around. So there's no crystal pattern here. There's no random pattern here. There really isn't a pattern much at all because they're constantly just moving around each other. We call things that can do this a fluid. So this is that ability to flow. So any substance that flows will be a fluid. I guess my picture's kind of in the word of there. I'll remove that there. There we are. So fluids are going to be consisted of gases and liquids. So keep in mind gases are fluids as well. You can think of that as airplane wings. The air, which is a gas, flows over the airplane wing. And here you are with liquids that are fluid as well. You can pour them from one thing to the next. And you can note that I have pictures of the Erlenmeyer flask here, which is kind of that triangular flask. So it gives you a little sense that, hey, this liquid took the shape of that container. Properties of liquids. One main property of liquid that you need to realize is surface tension. Surface tension is this inward pull of the molecules that bring molecules on the surface closer together. It prevents them from escaping a lot, and also provides like these water skimmer bugs to walk on water. A lot of times in water, this is a hydrogen bond that does that, creates more water tension. This is also when you jump off a bridge or something, not that any of you should be doing this, but jump from a high height into water, it tends to hurt when you first smack in there because you hit that water tension, that tightness between the molecules on the surface of that water. That can easily be disrupted with like an emulsifier like soap or something to spread it out, or just make something hit before you hit. And you can dive into water pretty easily. One of your assignments for this chapter is to actually get a paperclip to float on water. This is how that's going to be done, is by using this property of surface tension. So there are a few tricks that you might want to look up, see if you can find that'll help you with that assignment, because it's not going to be easy right away. You're going to have to try a few different things in order to get that to work. But you can make a paperclip float on top of water because of the surface tension. Another property of liquids is viscosity. Viscosity is a resistance to flow. You might notice that certain liquids you can pour easier than others. Water has a very, very low viscosity. It has a low resistance to flow. It pours very easily. Whereas you get something like molasses, which has a high viscosity. It doesn't want to flow much. It will still flow. It just takes a long time to do so. It's still a liquid, still has that ability to flow, but some things just flow easier than others, and that property is viscosity. Remember, viscosity is a resistance, so I am measuring how hard it is to flow. So if I have a high viscosity, then it doesn't flow very high, as you can see in our little graphic here. This substance here does not flow as well as this one here, and therefore it has a high viscosity. This one has a low viscosity. Next state of matter is gases. Gases do not have a definite shape or a definite volume. In fact, these particles have so much energy in them that they don't just vibrate in place. They don't just slosh around each other. They can actually break free from each other and shoot around. anytime we put a gas in a container, the gas is going to take the shape of whatever that container is. So the shape is going to be a little different depending on the container. So if I put it in an Erlenmeyer flask, then it takes the shape of that flask. It fills up the whole flask. It does not have a definite volume because I can condense these into smaller areas by increasing pressure-wise. And we'll look at relationship between gases and pressure later on. A lot of things with gases, different ideas of them. You cannot necessarily see them a lot of times. This structure here are cooling towers for a nuclear plant. This foggy stuff up here is not a gas. You cannot see this gas. This is water vapor coming off, and this is condensation that's forming. So keep that in mind. This is not a gas here, but we do know there is a gas present because these things, it is condensing. So it's cooling down. Those particles are slowing down and forming water molecules here. Another thing about gases is looking at our periodic table, we do have a whole column on there that we call our noble gases, and that's your helium, your neon, your argon, your krypton, your xenon as they go down. You probably know neon as the glowy orange-red color in neon signs. You probably heard me say before that neon is only orangish red. It does not get the other colors. The other colors are made by the other noble gases in that column. So you should take some time to look at that periodic table and see if you can find these elements on there so you know where my noble gases are. But these are naturally occurring gases.